Hey everybody, and welcome back to another fun and exciting geometry class. Today we'll be in lesson 4.13. That is on page 214 in your book, 214, and it's lesson 4.13, relationships of similar polygons. What does that mean? Well, a relationship is the way that two things interact together. Okay, I guess two or more, but in this case we have two things interacting together. So what is a similar polygon? It's a polygon that's the same shape but different sized. So think about this. Think if like you take the corner, like on a computer screen, you take the corner and you pull the corner, it keeps everything the same. It just makes the screen get smaller. You can do that. You can make the screen get bigger by pulling it from a corner. If you pull it from the side, it makes the screen change shapes, basically. If you pull it from the top down, it gets shorter. If you pull it from the side out, it gets fat. But if you pull it from the corner, the whole shape stays the same. So think about that when you're thinking about similar polygons here. It's like you take whatever polygon you have, a five-sided polygon, an eight-sided polygon, it doesn't matter how many sides, and you take it and you basically expand it up, so you make it bigger, or you shrink it down, but you're keeping the shape the same. The shape has to maintain. So in other words, all the angles are the same, but the sides are just going to be different lengths. All right, so that's what we're dealing with here. So look down here at the screen, and you can look in your book as well. You're going to see the same information. Relationships of similar polygons. Theorem 65 says the perimeter of two similar polygons are to each other as any two corresponding sides. What's going on there? Well, I've got two polygons, and these are similar. So in other words, this shape is exactly the same as this shape. The only thing that I did was I took it and I made it smaller. Okay? Angles are all the same. Sides are all proportional to each other. They are similar shapes. So what it's saying is it's saying that the perimeter of these two shapes, what's the perimeter? Well, the perimeter would be the distance around it. So from here to here to here, up to here, and then back to where you started. If I measure that shape all the way around the edge, I'm going to get the perimeter. So we'll call this one the perimeter of, the first shape. We'll just call it P. And this one, we'll call it the perimeter prime. Okay, and again, that's the shape all around it. As you go all around the edges and you measure every length, you would get the perimeter. What they're saying there is that the perimeter is proportional to any two corresponding sides. So what they're saying is that this perimeter right here is proportional to, let's say, C and C prime. Okay, and you could choose any one that you want, C and C prime, A and A prime, doesn't matter which one that you pick, because since these A and A prime are proportional, and since the perimeters are proportional, what you can do is you can put this ratio together right here. Okay, this is important. Perimeter over perimeter prime equals side A over side A prime, which also equals side B over side B prime, which also equals side C over side C prime, which also equals however many sides you have. Every single side could be part of this proportion. So how would you solve this? There's lots of different ways to solve these, but you would put something like, let's say that side C equals 7 and side C prime equals 3. Our perimeter in here is going to equal, I don't know, let's call it 36. All right. So I'm not going to, name everything, every side, but we'll just say that the perimeter adds up to these sides, in other words, would add up to 36. The question is, what is the perimeter of this smaller shape right here? Well, we can find that out because it's proportional. So we would just plug it in. So you plug in the proportion, and it was 36 over x. That's what we don't know. We don't know the perimeter prime. Equals, and that was the C one. It doesn't really matter. Any side would work there. And it's 7 to 3. So we go 7 to 3. And then we would just go ahead and solve that out. So 7x equals 36 times 3. And then divide both sides by 7, and you'd get x equals And then we can figure that out. So take your calculator and do 36 times 3 equals divided by 7 equals, and we get 108 over 7. So you could do 108 over 7, or you could also round that off to a decimal, depends on what it's asking for, and it looks like it's 15.43. So 15.43, and that would be x equals approximately 15.43, since we rounded it off. What's x? X is perimeter prime, so this perimeter would equal our 15.43. All right, next, let's go down here to Theorem 66. If two polygons are similar, then they may be decomposed into the same number of triangles similar to each other. What does it mean to decompose something? Well, like let's say that something dies, a plant dies, you cut off some grass, you're out mowing the yard, you cut the grass, and the grass that you cut is going to die. It's going to turn yellow and it's going to decompose. And so what decomposition is it's like a breaking down of that original state. In geometry, if you decompose something, you're breaking it down from its original state. So what it says is if we decompose these similar polygons into triangles. So in other words, let's go up here to angle C, and if I make a triangle at angle C, notice I made a triangle right here, right? So this would be what, CDE, that would be my triangle. And I'll make another one. I'll make one this way. This actually makes two more triangles. So ABC is now a triangle, and ACE is now a triangle, right? Okay. So what this theorem is saying, if we make the same number of lines in the similar shape, so if we do the exact same thing that we just did in the original shape, so let's go ahead and do that. So we'll go from C prime to E prime down here, and then we'll go from C prime to A prime. And what happens is we've made the exact same looking shape, right? So we've made the prime triangles here. So I've got 3 prime triangles, and I've got 3 regular triangles. Here's what they're saying. What you do when you do this is you've made the same number of triangles, and they're all similar to each other. Let's do A, B, C, right? A prime, B prime, C prime. Those are similar triangles. Okay, they look similar. Okay, they should look similar, but they definitely are, because if the original shape is similar, then the triangles that you create when you decompose the shape or you break it apart are going to be similar. Now, in shape decomposition, you should literally think like we could actually take that and we could actually move that triangle right out of there. So for example, I could take this ACE triangle right here, and I could actually just move it right out of there. What they're saying is this triangle that I decomposed, okay, that I broke apart, is going to be similar to this triangle right over here. And it is, right? So it's the same exact thing, except for it's just a little bit smaller. So we're actually, the word decompose means that you can actually literally take it apart, break it down. All right, next is Theorem 67. It says that the converse of Theorem 66 is also true. In your book, they actually write out Theorem 67. You can read it, but I just summarized it. The converse of Theorem 66 is also true. What does that mean? It means that we can take these similar triangles and we can put them together to make a shape. When we do that, the shape that we put together, that we construct, that shape will be similar. Okay, so we could take 2 triangles that are similar. I'll use 2 right triangles. Okay, so right now they're decomposed, they're separate, and then what I'll do is I'll make some that are similar to these ones. So we'll just kind of shrink these down just a little bit. And it might not come out exactly right, but it'll come out pretty close. And I'll Shrink this one down. Now, what they're saying is if these two triangles are similar, and they are, so in other words, this one, and I can label this, so I'll label this A, B, C, and we'll call this one D, E, and F. So we'll label these the same. So D prime, E prime, and F prime. And over here, we're going to have C prime, B prime, and A prime. So what we're saying here is if these two triangles are separate, when we actually join them together, the new shape that is made, in this case, we're still going to have a triangle, but the new triangle that's made will also be similar, just like the triangles were similar. So if we come over here and we actually take and we join these two together, that new shape that we make here and the new shape that we make over here, they are going to be similar. And you can kind of see visually, you can see that. So when you start with deconstructed triangles or shapes, and they're similar, when you put those together, the new shape that is created is also similar. So that's one way that you can find similarity, is saying, okay, this small piece and this small piece were similar. So when I join those pieces, then the resulting thing is also similar. So when you break them down, like we did here, they're similar. And when you put them back together, if they start, the key is they have to start similar. And then when you put them together, they're still similar. When you tear them apart, they are also still similar. All right, that's all I have for you in this lesson. Hopefully you learned something there. A little bit shorter lesson. After this, there's like 4 lessons of just working problems. So let me encourage you, try your best there. Geometry is hard. It's supposed to be hard. And but here's the thing, you have the tools that you need. It's like you're a mechanic, right? And you are working on your car. Well, you need certain tools in order to be able to work on your car. So you need to put these tools, these theorems, these corollaries into your toolbox so that when you need them, when you need the right wrench or when you need the right whatever it is to work on your car, you know right where it is. You're like, oh, okay, I can go get that right there because I remember learning about that. That's kind of the concept of how to do these exercises. You learn the concept and then you really work through, and there's a struggle there, okay? I don't know too many students that, oh man, these exercises are so easy. They're not easy. So what you have to do is you have to work hard at them. You have to think through them. You're using logic. That's what geometry is doing to you. It's forcing you to use the logical part of your brain. So, all right, little encouragement. Next 4 lessons are going to be challenging, but get in there, work hard, sort through it. Try to remember the tools that are in your toolbox so that you can solve these problems. All right, that's all I've got for you. If you missed anything, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.